All right, now we're going to generalize for finding nth roots. So instead of specifically taking square roots or cube roots, we could really be asked to find any root. The index does not have to be 2 or 3. Remember, the index is the root you are taking, right? So it would look like the nth root of something. So we could take the fourth root of 16. So that would have a 4 here as our index, and we would say the fourth root of 16 is 2 because 2 to the fourth power is 16. It's always the same idea. The index is telling you how many times you need to raise a number to get to what's underneath. Okay, so if we take the fifth root of 1024, we're looking for what number we would need to use 5 times. Well, that would be 4. The sixth root of 1 is 1. Actually, any root of 1 is 1 because 1 can be multiplied with itself as many times as you'd like, and you still get 1. The negative fifth root of 32 is what number do we need 5 times? So 2, and the negative is a tag-along. Now we get to the fourth root of a negative number. And this again is a problem because we're looking for what number to the fourth power to get this negative 625. We can't take a number 4 times and end up with a negative. So this is no real answer. So a further discussion of question 4, if the index, the root you are taking, is even, such as 2, 4, 6, and so on, the radicand must be positive. Remember, the radicand is what sits underneath the root, right? So a little concept check here. Which of the following is a real number and which is not? This is not a real number, because our index is even and our radicand is negative. This one is not a real number. Same idea, our index is even and our radicand is negative. This is a real number. This is possible because the index is odd. And this one, the index is even and the radicand is positive. So this is possible. So finally, what is the meaning of the nth root of a equal to b? Well, it means b to this power is equal to a. All right, now we're going to get into some definitions here. All right, so things we already know. We're going to kind of peel apart the nth root of a. That's what we're going to consider. So a is the radicand. N is the index, or sometimes it's called the order. And if you put the whole thing together, you get what we call the radical expression. So this is what we have learned so far. If n is even and a is positive, then the nth root of a represents a positive answer. And if there's a negative in front of it, we get a negative answer. If n is even and a is negative, then we do not get a real number. We have no real answer. The last case is if n is odd, then there is exactly one real nth root. It could be positive, it could be negative. So now we're going to talk about simplifying radicals containing variables. So we're going to consider the following expression, the square root of a squared. Well, we might guess that this answer is a because a times a is a squared. And remember, this says we're looking for some value to square to get back a squared. Well, a squared would be a squared. Well, we can't actually guarantee this, all right, because we're just guessing. So let's look at a specific example. In mathematics, when you guess, sometimes to see if it works or not, you just play it out with a specific value. So how about we let a be 6? So then a squared would be 6 squared, or 36, and the square root of 36 is 6. So we were suggesting that the square root of a squared equals a. Well, look, the square root got us 6, and that got us back to 6, right? So this one worked out. Well, let's change what a is. Let's let a be negative 6. Okay, so a squared would be negative 6 squared, which is 36, because a negative times a negative is a positive, and then the square root of that is 6. Well, look, that doesn't get us back to negative 6, so my guess is wrong. My guess of a, this right here, is wrong. Because I don't always get back a when I take the square root. So here's what we need to know. Since the symbol square root of a squared represents the positive square root, we express the square root of a squared with the absolute value of a, because that way our answer will be positive. So in summary, the square root of a squared is equal to the absolute value of a. So let's look at some examples. So the square root of 15 squared, well, what does it say? What's being squared? 15. So we get the square root of 15, which we clean up to 15. This one, it says whatever's being squared is what sits inside of the absolute value. So this is the absolute value of negative 12, which we clean up to 12. Anytime it's just a number inside of the absolute values, we can finish it to a value. Now here, instead of a squared, we have y squared, so we're going to say the absolute value of y. And we can't do more with that because y is a variable and we don't know what it represents. This one, what's being squared is negative y, so we get the absolute value of negative y, which we could clean up to the absolute value of y because the negative would go away. Now notice, these are specific answers when dealing with a square root. Be careful what index we have here, right? The index of 2 is never shown, but we're doing a square root right there. All right, well now let's consider roots other than square roots and what has to be true. Well, we're taking a 6th root and a 5th root, right? So we have to know some rules. If n, remember n is the index, if n is even, then the nth root of something to the nth power is the absolute value of a. It follows along with the square root idea because square root is an even n, so it's still the same. If n is odd, like right here, then we just say our answer is what a is. All right, so let's practice this out. These can get a little tricky, so just stick with your homework and try them out. So we're looking at an even power. The same power matches inside, so it says here that our answer would be the absolute value of a. So we're going to get the absolute value of negative 2 or 2. This one, we have an even power, so we're up here with the absolute value of what a is. So a is the value being raised to the power, so negative 7. So we get negative absolute value negative 7, which this cleans up to 7, and this negative is a tag along. So we get negative 7. This one. This is a negative 8 in here. Now look, is that an odd index with a matching odd power? So our answer is just what is the value that is raised to the power. So our answer is negative 8. This one right here is kind of tricky because you can identify that it's an odd index, but there's no power inside. Well, what's true about a -1 is you could put it to the 7th power and you would still have -1. -1 multiplied 7 times is still -1. Now you can see that it follows this rule where the odd index has the same odd power, so our A is -1. So we carry this negative and we bring down the A that's inside, and then a negative and a negative make a positive. Okay, so now let's look at it with variables instead. It's still the same idea. Odd power, same matching odd index, same matching odd power, so our answer is X. Here, even index, matching even power, so our answer is absolute value, X. Now here, the trick is the rule says that the inside power matches the outside index. Well, I don't have that. But I could write this. I could see how many times 3 goes into 33. So I could say x to the 11th power to the 3rd power. Because our rules of exponents is a power to a power we multiply, so this is 33. Now I see the inside power matches the outside index. So my answer is x to the 11th. So we could do the same thing here. We could say that this is x to the 7th times 6, because 7 times 6 is 42. Now this is an even power, so even power with matching even index. I have to use absolute value, so I get absolute value x to the 7th. And I don't know the variable, so that would be my final answer. So here's the summary. If you are not told to assume that the variable represent positive real numbers, you must use absolute value on variables when taking an even root.